Hello, Legacy Sabers. Today we're going to be talking about inverse functions. So far we've talked about what a function is, how to define a function, how to operate with functions, and then how to compose functions. And now we're going to need our notes and a pen or pencil to talk about the inverse function and what that is. So our learning targets today are twofold. The first being that you can describe how to find an inverse, and the second being I can find an inverse given a table, graph, or equation. So being able to do not just one of those three, but all three of those, finding an inverse given a different situation. Okay, so remember back to that first foldable of functions when we talked about the function machine where we input something, we calculate it in the machine, and then we get a different output. So in that same respect, we're going to imagine if functions are like the dye used to color Easter eggs. So the white egg would be the X or the input that is put into the function, which would be the blue dye, or let's say B of X, and the result would become the blue egg or the Y. So we have this picture that represents how we started with a white egg and ended with a blue egg, just like how a function changes it to get a different output once we've put in an input. So when using the same egg example, the inverse function undoes what the function does then. So the inverse function in this egg example would be like the blue dye, or it would be like bleach for the blue dye because we're going the opposite way. We would have started with a blue egg and now we want to get to a white egg. So the bleach will undo the dye that the blue egg to make it white. So we have this picture again for us. We started with a blue egg and then we're getting a white egg. So inverse functions are something that undo the regular function. That's the main key for today. And you don't have to write down this egg example in your notes. Remember that we're looking for that pencil in the top right hand corner when we need to write something down in our notes. So in that same way, we're going to look at a real function so that the inverse undoes that given function. And this example that we're going to look at is f of x equaling x squared, or the square function. So let's say that my input is 3, and then once we plug it in to that function, our output is 9, because 3 squared is equal to 9, or 3 times 3 is 9. So now we have to figure out the inverse, or how we go from 9 to 3. We want to go the backwards route to undo what we just did. And we know that a square root undoes a squared. So to get from 9 to 3, I have to take the square root of 9 to get back to 3. So our square root function would be the square root of x. So our function that we started out with was x squared, and the inverse function would be the square root of x. And so that's what we're trying to do today with functions and inverses of functions. And now if we do the same thing but with a different number, we'll see that it works both ways. What if we inputted the 11 into our x squared function? 11 squared, or 11 times 11, is 121. And in order to go from 121 back to 11, we have to take the square root of it, because we know that the square root of 121 is 11. So that's just another example with a different input. So now we get to write the formal definition in our notes, and see that pencil up top here? That means that we should be writing this whole slide in our notes. So the inverse function undoes what the original function did. If the original function is f of x, then the notation for its inverse is f inverse of x. So if the original function just has this f in front of the x, then its inverse is represented like this, where it's f to the -1, like an exponent of x. So this is f of x, and this is the inverse of f, or the inverse function of x. The function takes an x value, the regular function takes an x value and produces a y value, and we know that from our function representations like the machine. And whereas the inverse switches this role. To find an inverse, we need to switch the x and y, and I'll show you what I mean. Okay, so you do not need to write this down in your notes, just listen along with me. So we're going to talk about switching the y and x values and what that looks like graphically. So if I was given the point 4, 7, then the inverse point would be 7, 4. It would have the inverse of switching that x and y. So if I started at 4, 7, its inverse point would end up here. What if I started with the point -5, 3? So if I started here, then we're saying that the inverse point of that is just switching the x and y. So now we would have an inverse point of 3, negative 5. So that's what I mean when we talk about switching the x and y values graphically. We're just switching the coordinates of x and y and those points. Another way that we can understand switching the x and y values is if we were to look at a table. So if this little red table of x and y values generated these little points on this graph, then all we would have to do to find the inverse function is to switch those points, just like we did with when we were given points. So all of the x values become y values now in our table, and all of the y values become our x values in the table. And so if we look at the graph after we've plotted these points on of these tables, we can see that these two functions, the regular function and the inverse function, are a mere reflection of each other. And the reflection, or the line of reflection, would be right through the middle. And this line is particularly the line y is equal to x. We have a slope of 1 and we're starting at the y-intercept or at the origin of 0, 0. So two ways to think about this. Graphically, a function and its inverse have a line of reflection, so it's just reflecting it over a line, y is equal to x. Or if we think about it in a table version, we're just switching the x values and the y values and then replotting points. So two ways to think about it. So now it's time to go back into our notes and try some examples for on our own. So we are given the graph f of x on the left, and we need to graph the inverse function of f on the right. And they've conveniently given us 5 points. So all we need to do is switch the x and y values of those 5 points. So I'm going to start with the point 1, 7. And now I need to switch my x and y. So it's now going to become the point 7, 1, which means that I need to go to the right 7 and up 1, and that's my new point. I'm going to start on this next point here, 0, 1. Now I'm going to switch my x and y, so now it becomes 1, 0, which means that I go to the right 1 and up nothing. My point down here is negative 1, 1. Well, that's easy. When I switch them, it's the same thing. So negative 1 is the point right here, same point. Now we're going to move to this point, negative 2, 1, switch the x and y values. So now my new point is going to become 1, negative 2, which means to the right 1 and down 2. And now my last point is negative 3, 7, and we're going to switch that x and y value. So it's going to become 7, negative 3, so to the right 7, down 1, 2, 3. And now let's connect those points. And that, ladies and gentlemen, is as simple as graphing an inverse. All we have to do is find points that we can identify on the graph, and the example they gave us were nice enough to give us point values, and then switch the x and y's and graph those points. So that's that example. Now let's do an example where we're creating an inverse table. We have two parts to this problem. First, part A, we've been given the function h of x is equal to 2x plus 1. And we need to create a table of values for the function using the domain. Well, the domain is the same thing as x values, so I can just plop these x values into my x column. So negative 2, negative 1, 0, 1, 2. And now h of x is the same thing as y, remember? So in order to find my y values, I just have to plug in each of my x values into my function. So we're going to have 2 times negative 2 plus 1 for my first entry in the y or h of x column. Negative 2 times 2 is negative 4 plus 1 is negative 3. Now we're plugging negative 1 into this function. So we have 2 times negative 1 plus 1. 2 times a negative 1 is a negative 2 plus 1 is a negative 1. Now if we plug in 2 times 0 plus 1, 2 times 0 is 0, plus 1 is 1. 2 times 1 plus 1 would be 2 plus 1, which is 3. And last but not least, we have 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So that is my table for the original function h of x. And now part B is asking me to create a table for the inverse function. I know that it's the inverse function because of this notation, right? That little negative 1 is telling me inverse. So all we have to do is switch our x and y values, or our h of x and x values. So this column is going to become my x column. So -3, -1, 1, 3, and 5. And then my x column is becoming my h inverse of x, or the inverse function of h. So -2, -1, 0, 1, 2. And that's that. So far in the last two examples, we have been switching values that have already been given for us. So finding the graph was easy because we had points, we had actual numbers for x and y that we could switch. For the table, even though we weren't given the y's, we could find the y's because they gave us the x's. But now in example 3 and in example 4, which we'll do in a second, we have to actually find the inverse equation without any values for x or any values for y. We're just simply finding the inverse equation. So what does that look like and how are we going to do that? So our function is f of x is equal to 6x minus 12, and we need to find the inverse. And I know, as much as I know about inverses, I have to switch the x and the y. That's what I've been saying repeatedly over throughout the notes. So in this original function, remember how f of x is actually the same thing as y, right? So f of x is the same thing as y, so we can rewrite our function as y is equal to 6x minus 12. Same function. This is what we started with. I'm just replacing f of x with y because I told you that we need to switch the x and the y. So now we're just going to simply switch the x and the y because that's my first step. So we have to now become, if we switch the x and the y, it now becomes x is equal to 6y minus 12. And now what I have to do, ladies and gentlemen, is I have to solve for y in order to create my equation, because whenever we talk about equations, we always have to solve for y. We don't like to leave it as x is equal to something. So if I have x is equal to 6y minus 12 and I need to solve for y, I have to isolate y. So reverse PEMDAS. So my first step is going to be getting that 12 away. So if I undo a negative 12, I have to add 12, and whatever I do to one side, I have to do to the other side. This cancels. X plus 12, that can't be combined. They're not like terms. So that becomes x plus 12 as a phrase, and we just bring down what we have left over, 6y. Still haven't gotten y isolated, so I have to divide by 6. That's the opposite of multiplication. Whatever I do to one side, I have to do to the other side. Divide by 6. Now, 12 is divisible by 6, but x is not. So I'm going to just leave that big fraction just as it is. So we have y is equal to x plus 12 in the numerator, all divided by 6. And remember, this y is representing my inverse function, so we're going to write it as f to the -1, or f inverse of x is equal to x plus 12 divided by 6. And that is my inverse equation, or my answer. Let's try one more example. Same set of directions. Given the function g of x is equal to 3x plus 1 divided by 2, find the inverse of g. So we remember that our first step is to switch the x and y, and my y is disguised right now as g of x. So my true function that I'm starting with can be written y is equal to 3x plus 1 divided by 2. And now I have to switch that x and y value, and that'll get me x is equal to 3y plus 1 divided by 2. And my last step is to solve for y. So we have x is equal to, I'll just rewrite it here, 3y plus 1 divided by 2. So now we have to do reverse PEMDAS to solve for y. So y is getting multiplied by 3, then added by 1, and then divided by 2. So the first step we have to do is multiply by 2 to get rid of that denominator. So 3y plus 1 over 2 times 2 over 1 is going to cancel those 2's, and whatever we did to one side we had to do to the other side. So now we have 2x is equal to 3y plus 1, and now we can solve just a simple multi-step equation. So subtract 1 from both sides. 2x minus 1, we can't combine that, you guys, because they're not like terms. So we're going to leave it as 2x minus 1 is equal to 3y, and our last step is to divide by 3. And remember, 3's cancel, and we can just leave this big fraction as it is. And remember that our y now is going to become the inverse function. So we have g inverse of x is going to be this phrase, 2x minus 1 over 3. And that is my final answer. Thank you everybody for taking good notes, and I shall see you soon.